So what's the sine rule about? Well, it's just another branch of trigonometry. Now, you've probably already covered basic trigonometry, where you can find missing lengths or missing sides in triangles that have a right angle. So the sine rule is about finding missing sides and missing angles in a triangle that doesn't have a right angle. It really is as simple as that. So we use basic trigonometry for right angle triangles, and we use what's called the sine rule and the cosine rule, we'll come back to that later, to find missing sides and angles in non-right angle triangles. So to summarize, the sine rule is just used to find missing angles or sides in non-right angle triangles. Before we look at what the sine rule is, we need to make sure we have the diagram labelled correctly. Now, in labelling the diagram, we start with the angles. This angle here, we recognise this to be angle A. This angle here, I'm going to call B. And this angle here, I'm going to call C. It doesn't matter which one of these is A, B, C. Just make sure you label them A, B, C. And then label the opposite side. So looking opposite that angle, we're looking this way here. Label that opposite side lowercase a. Label the opposite side lowercase b. And again, the opposite side lowercase c. Get the labeling right. The rest becomes very simple. Okay, so now we've labeled the diagram. What's the formula? Well, we've got one formula, but we show it in two different ways. If you're looking for a side, so you're looking for the length of a side, the formula you're going to use has the lowercase sides as numerators. So we got length A over the sine of A is equal to B over the sine. B is equal to C over the sine of C. Now, if you're looking for an angle, we just flip that. So we're going to go sine A over A is equal to sine B over B, which is also equal to sine C over C. So how do we get the sine rule? Well, we derive the sine rule from using basic trigonometry. So if we start with a right angle triangle, we know that the sine of theta, the sine of an angle, is equal to the opposite side over the hypotenuse. We're going to use this to derive the sine rule. So the first thing we'll do is label this triangle. What we're going to do now is drop a line from C perpendicular to the length C. So we get two right angle triangles. We're going to call this here the height of this triangle and the height, the perpendicular height of this triangle. So we're going to call that H, and we'll call this point here X. So what we're going to do next is we'll look at the triangle ACX. Okay, so let's look at this triangle. We know from basic trigonometry that the sine of this angle is equal to the opposite divided by the hypotenuse. The sine of angle A is equal to the opposite, which is H, over the hypotenuse, which is B. Now, let's look at this triangle. Okay, so let's look at this triangle in the same way. We know that the sine of B is equal to the opposite side, which is H, divided by the hypotenuse, which is A. The key thing to recognise here is we've actually got H in both equations, so we can make both of these the subject of H. So I'll do that here. So now I have H is equal to B multiplied by sine A, and on this side, if I multiply both sides by A and then cancel there, I have H is equal to A multiplied by sine B. So if we look at this, H equals B times sine A, and H also equals A times sine B. So we can combine these. We have now got A sine B is equal to B sine A. I can divide both sides by sine A and both sides by sine B. If I did that, I will end up with A over sine A is equal to B over sine B. Now, because things are symmetrical, I can also do this. So now we have derived from basic trigonometry the sine rule. So this here is your sine rule. In the next few videos, we're going to use this to find missing angles and missing lengths in non-right angle triangles. Well done on getting this far.